In this short presentation, we're going to look at some of the problems when creating Python packages from FPGA designs and some of the tools in PYNQ to help overcome them. When we were moving from PYNQ for embedded to PYNQ for Datacenter, there were two issues that we ran into. First, there was no standardized place to put the Jupyter notebooks that we want to include with the design. And secondly, PyPI has an upper limit of 60 megabytes for packages. Each bit stream can be larger than that on its own, and in order to support the range of Alveo and cloud platforms that are out there, we ideally wanted multiple bit streams for each design. Looking first at the issue with locating notebooks, the solution we arrived at was a PYNQ get notebooks CLI command and a way for packages to register the notebooks they contain in a unified way. To show how this works, let's switch over to the command line where I've already copied in the source for the example package from the Python packaging tutorial, linked below. We're going to add a notebook to this package. The first step is to actually add the notebook to the package by creating a folder inside the Python package and adding our new notebook there. Setup Tools doesn't know how to handle IPYNB files, so by default it will ignore them when packaging the project. The easiest way to resolve this is to create a manifest.in file and recursively include the notebooks folder that we just created. With the notebook now included in the package, we next need to make PYNQ aware of the notebooks folder. We do this using entry points, which are a well-defined way for packages to offer extension points. To attach to an entry point, we use the entry points argument to the setup function. This is a dictionary of the entry point to attach to and the value to attach. For PYNQ notebook discovery, the key is simply pynq.notebooks. The value is the subpackage containing the notebooks and the folder you want them copied into when PYNQ get notebooks is called. For this example, our subpackage is example package.notebooks, and we want this to appear in the example notebooks folder. With all this set up, we can now use pip to install our new package and verify the notebook folder was found correctly by PYNQ using the PYNQ get notebooks list option. And then finally check that when PYNQ get notebooks is called, our notebook appears correctly. With the issue of deploying notebooks resolved, we can now move on to the second problem of handling large files. Here there are really two sub-goals. The first most obvious one is to move large files out of the Python repository, which helps not just with distribution but also source control. The second goal relates to most of the large files we see being bit streams, and we don't need to download bit streams for devices that the user doesn't have. With those two goals in mind, we introduce the link file, which is simply a JSON file containing the URLs of the files that should replace this link file when the package is installed. There are two flavors of link file, the generic and the board specific. As a motivating example, let's suppose we've created a design for data compression and we want to include a large file to act as some test data for our notebooks. In this case, we don't care what board we are using, we will always want that file. Going back to the command line, to do this, we create our testdata.bin.link file and populate it with a JSON dictionary of a URL and an optional MD5 checksum. To get PYNQ to download the link at install time, we need to modify our setup scripting in. PYNQ introduces a new download overlay setup tools command, which downloads the links. The easiest way to have setup tools call this command is to use PYNQ's replacement buildpy, which downloads the overlays as part of the package build. This can be done through the command class argument of the setup function. If we now reinstall the package and call PYNQ get notebooks again, we can see that testdata.bin has been downloaded and now resides in our notebook folder. Board-specific link files are similar in structure but contain a dictionary of shells, where the key is the shell name and the value is a link dictionary as previously described. Either when installed or get notebooks is called, only the link for the shell installed on the system is downloaded. That wraps up our presentation on how PYNQ can help with packaging of FPGA designs. If you have any questions or comments, feel free to head to our forum, which is linked below. Likewise, if you create your own FPGA package, let us know. We're always on the lookout for new projects to promote through our community page.